Okay, in this lesson we're going to use the law of sines to solve triangles. The pattern of givens when you use law of sines to start solving is going to either be the angle side angle or angle angle side with only one possible solution. And there's another case, the SSA, which is side side angle. This will give us 0, 1, or 2 possible solutions. First thing I want to do is prove the law of sines, or at least one of the cases of law of sines. In order to do so, I'm going to take this triangle ABC and I'm going to drop an altitude or a height from the point C down to the base AB, and let's call that H for height. Now I'm going to consider the two right triangles that have been formed. Notice that we're forming two right angles there at the base of the triangle. And so let's consider this first triangle that I'm highlighting. If we consider that one and we think about angle A, then the sine of angle A is equal to the opposite side H over the hypotenuse B, which if we multiply by B, that gives us B times the sine of angle A is equal to H. Now let's consider a different triangle. Let's take the triangle on the right side here, and now let's think about angle B. So angle B's sine ratio is sine of angle B equals the opposite side H over the hypotenuse A. If we take and multiply both sides of this equation by A, we get A times the sine of angle B is equal to H. Notice that we've solved for H in two different equations. That means that those two H expressions must be equal to one another. So B times the sine of angle A is equal to A times the sine of angle B. The next thing that we can do is take and divide both sides of this equation by A times B. If we do that, we can cancel some common factors there of B on the left side and A, on the right. So we're going to cancel just the A's on the right, and you'll notice that what results once we rewrite this is sine of angle A divided by the measure of side A equals the sine of angle B divided by the measure of side B. And that is the law of sines, or at least one of the parts of the law of sines. We can prove the rest by drawing altitudes in different places. All right, so how are we going to use this? And we're going to make heavy use of your calculator here. Sketch each triangle, identify the pattern of givens, and then solve the triangle. Solve the triangle means we're going to find all the rest of the sides and angles. When it's appropriate, we're going to state that there's no solutions or find two solutions for the triangle and round to the nearest thousandth. In A, we have a triangle ABC. I'll begin by sketching and label ABC. It doesn't matter what order you label it in as long as we're consistent. So the measure of angle B is 64 degrees. Side B's length is 9. The measure of angle C is 38 degrees. We're always going to start with the easiest thing to find, and that easiest thing would be the third angle. In this case, if you're given two angles, immediately find the third angle. That will be the easiest thing to do. So that will be a 180 minus 64 minus 38. And I'm going to grab my calculator and do that calculation. So we want to grab a calculator page there. 180 minus 64 minus 38 is 78 degrees. So measure of angle A is equal to 78 degrees. I'm going to go ahead and circle things as I find them. I'm also going to take and I'm going to put these measures in my diagram so that we can make sense of them and identify if this is a reasonable solution. All right, next thing we need to do is find the missing sides now that we have all three angles, and we'll do that by using the law of sines. So I'm going to start with sine of 64 degrees over the opposite side, 9, is equal to sine of 38 degrees over the opposite side, which we should call C since it's opposite vertex C. By the way, you don't have to start with that one. In this case, you can find either side easily first. Now let's cross multiply. C times the sine of 64 degrees is equal to 9 times the sine of 38 degrees. And now divide through by sine of 64, and C is 9 times the sine of 38 degrees divided by the sine of 64 degrees. Let's grab our calculator and do that computation. And you'll want to use control divide for a horizontal fraction bar. 9 times the sine of 38 degrees divided by the sine of 64 degrees, and enter, and we get 6.165. Now, I know that I'm using equal signs, and I should truly be using approximately since we've approximated this, but that's a real pain to do, and it's equal as long as we're considering equal to the accuracy of the third decimal place, so I'm not going to get fussy about that. All right, since I solved for that one, I'm going to go ahead and place that in my diagram, and then later when we find the last part of the solution, we will compare some things and determine the reasonableness of this. So we have one more side to find, and that would be the side that's opposite the 78 degree angle. So I'll start with sine of 78 degrees divided by the measure of side A is equal to, and I'll just use sine of 64 degrees over 9 again. You could use sine of 38 over C, but then we'd have to use that answer that I rounded off, and that's probably not in our best interest. All right, let's cross multiply. A times the sine of 64 degrees is equal to 9 times the sine of 78 degrees. And then divide by sine of 64. A equals 9 times the sine of 78 degrees divided by the sine of 64 degrees. And you'll notice that this calculation is very similar to the one that we did before. And so I can just cursor up to the previous calculation, press enter, and edit this. So instead of 38 degrees, we're just inserting 78 degrees. We have basically the same calculation. That's 9.795. I'm going to go ahead and box this answer in. I'm also going to place that answer back in our diagram, 9.975. Now, if you look at the diagram, what you're going to notice is the largest angle, 78, is opposite the largest side, 9.975, and then the smallest angle, 38 degrees, is opposite the smallest side, 6.165. That is a kind of a helpful check to make sure that our answer sort of makes sense. All right, let's check out another example, triangle BAM. So for triangle BAM, I'll draw first. And in this one, we have side A, which is opposite angle A, is 10. The measure of angle B is 40 degrees, and the measure of side B is 4. So we didn't do this on the last one, but the pattern of givens here is a side-side angle. And that's kind of important because that means we might get 0, 1, or 2 solutions. We notice we can't find the third angle because we don't have 2 angles given. So we're going to have to find an angle to start with, but by using the law of sines. So using the law of sines, sine of 40 degrees divided by 4 is equal to the sine of angle A divided by 10, which is the opposite side. Let's cross multiply here. So 4 times the sine of angle A is equal to 10 times the sine of 40 degrees. And sine of angle A is equal to 10 sine of 40 degrees divided by 4. To find measure of angle A, we need to take an inverse sine. So the inverse sine of 10 times the sine of 40 degrees divided by 4. And now we're ready for our calculator to find that angle. So inverse sine is in your trig menu. And I'll use the horizontal fraction bar, control divide, and enter 10 times the sine of 40 degrees divided by 4, enter, and you'll notice that we get undefined. That means that this calculation did not yield a solution, so this triangle actually has no solution. This is our SSA case where we have no solution. And then if there's no solution on that angle, there's no solution for the triangle, so that means we do not need to proceed. All right, let's check out the next one, triangle DEF, with measure of angle D equal to 42, measure of angle E equal to 61 degrees, and side F's measure is 65. So let's label those angles appropriately, and we've got side F is 65. Looking at the pattern of givens here, this is an angle side angle, and that means we're going to use the law of sines, but this one is one of our easier ones because we can find that third angle first. So we always want to start with whatever is easiest to find, and that third angle is 180 minus 61 minus 42, and so measure of angle F is equal to 180 minus 61 minus 42, and that value is 77 degrees. I'm going to go ahead and box that answer, and then I'm going to include it in my diagram here for future use. Now we can find the missing sides by using law of sines. It doesn't matter which side we find first. So I'm going to start by using the sine of 77 degrees over 65, since that's a pair of angles and sides that I already have, and then set that equal to the sine of 42 degrees over the opposite side D. Let's cross multiply. D times the sine of 77 degrees equals 65 times the sine of 42 degrees, and so that means that D is 65 times the sine of 42 degrees divided by the sine of 77 degrees. Now, let's just get our 3 decimal place approximation of that value. By the way, if you don't like your messy calculator, menu 15 will clear it. And so now I'm just going to start with a new fraction here, 65 times the sine of 42 degrees divided by the sine of 77 degrees. And that'll give us 3.434. I'm going to go ahead and write that one in on my diagram. And that side seems kind of small, so I'm going to look back at my calculator and make sure that I typed everything correctly. I actually didn't. So let's go up and edit that calculation. Why was I suspicious of that answer? Well, because one of the sides was measured 65, right? And so a side of 3 is probably pretty unlikely in that same triangle. So let's edit this calculation here and our final result. So the final result should be 44.638. And I want to indicate that down here as well and box that answer in. That'll make it easy for me to find your answers. Make sure that your work is organized and that you box your final answers. All right, let's find that third side by using the law of sines again. Sine of 77 degrees over 65 is equal to sine of 42 degrees. Whoops, already used that one. So what do we need now? Sine of 61 degrees over the last missing side, which is side E. So cross multiplying, e times the sine of 77 degrees equals 65 times the sine of 61 degrees. And then dividing, e is equal to 65 times the sine of 61 degrees over the sine of 77 degrees, or divided by the sine of 77 degrees. Let's bring up our calculator. You'll notice that this calculation is very similar to the one that we just did. So I'm just going to bring that calculation on down and change that 42 degrees into 61. Enter, that's 58.346. So E is 346? Let's box that in. Let's transfer that over to the diagram so that we can make sense of this. 58.346. And I want to just take a moment to look at my diagram here and make sure that the largest side is opposite the largest angle. 77 degrees is opposite 65. And that the smallest is opposite the smallest. Our smallest angle is 42 degrees, and the smallest side is 44.638. Answer, it seems reasonable. Okay, we're going to pause there, and the rest of the video will be in a part 2.